¿A dónde te vas?
Me
Ay,
encontré
no.
una amiga que también trabaja aquí, que conozco desde la primaria.
Hoy está Rodrigo adentro, luego continuamos.
Ah. Ipsi.
Hola, profesor.
Hola.
Hola, bro. Hola, bro. La colada le dicen.
Prof, Janina, prof.
Gustazo. ¿Profe de qué? Es de energético. Ah, TUEET. Sí,
Eso.
Eso. ¿Ya listo para responder, Felipe?
Ujú.
Oh.
¿Ahorita?
Pero ¿cómo? Claro, güey. La chingonería va primero.
Felipe, te voy a hacer un segmento en YouTube especial para recortes de todas las grabaciones. Sales diciendo alguna cosa.
No, ¿se acuerda el día que estábamos, no sé, creo que fue de las primeras videoconferencias?
Güey, pero es que no lo digas porque
Eso hace
están grabando, le están grabando, güey.
Estaba grabado que sí.
Pero ¿cómo? ¿Le mandamos la presentación o usted deja que
Ustedes
compartir?
la comparten.
Oh, wow.
Le quito
A la
el
hora que
silencio. Ajá, ustedes le quitan el silencio a sus micrófonos, presentan y listo.
No, primero va Felipe.
Ajá.
O sea, por eso,
Primero a
güey.
Felipe, luego Fernanda y Martín.
Sí, sí,
Ahorita nada más la descargo la presentación.
¿Ya empezamos?
Ya casi. Vamos a darles un par de minutos a ver si alguien más se conecta.
Ay, disculpe.
¿Qué?
No, nada.
Por ese güey que está en el espacio, cabrón, o algo así.
No te escucho nada.
Pues si quieres yo la presento, Génesis.
No.
Porque se escucha interferencia en tu móvil.
Soy equipo con...
Le voy a cerca del modem.
No se te escucha nada. Pareces extraterrestre.
¿Yo? Ahí voy. Es que, ¿sabes? Mi internet está muy mal últimamente. No sé por qué. Por eso no hay de tu licencia.
Ya no ando todavía, ¿verdad?
¿Ya se escucha?
Sí, más o menos.
¿Qué pasó?
¿En dónde estás, Isabel?
Pero ¿puede creer que se fue de viaje?
¿Y sí?
¿En serio? Órale. Qué internacional se está volviendo esta clase, qué cosa.
Profe, ¿ya vamos a tener clases en los siglos el siguiente semana?
Pues no que me hayan dicho. No sé.
Es que una maestra me dijo eso, pero quién sabe.
Pues a mí no me ha llegado ningún correo ni ningún comunicado al respecto. Entonces no tengo idea. Pero puede ser, puede ser.
Pues sí.
Vale, pues órale, Felipe Génesis.
Espere.
¿Por qué? Entonces, ahí en el botón verde que tienen en el Zoom, le pueden poner Share Screen y pues seleccionan el programa que quieren compartir y pues ya lo comparten. Mientras Diana codifica lo que digan en letra.
A ver, ya le puse.
Ya estás ahí.
¿Ya les parece?
Ya nos aparece.
Ya.
Ah, ok. Do we have to present in English?
Of course, darling.
Ay, no, profesor.
It is an English class.
Okay. So
Who starts?
hi everyone, and we are going to present the updraft fixed bed gasifier. The team is composed by me, Genesis, and Ian. Heh. Uh,
Okay.
so the brief history that we found is that the first commercial updraft gasifier was installed on 1839 when Bishop patented a simple process for gasifying coke. Also, this kind of gasifier is the oldest one and simplest from form of a fixed bed gasifier. Oh.
Oh, sí.
And this is the principle of operation. The biomass fuel enters from the top of the reaction chamber, and the gasifying media or engine, that is the air, the, the O2 and or mixture, enters from the bottom of the unit, that is from here. Then the fuel flows down slowly through the drying, then the pyrolysis, the gasification, that is reduction, and combustion zones, that is those. The ash is removed from the bottom. And finally, the main product desired in the gasification is the syngas, also known as syngas, which is a gaseous mixture composed mainly of carbon monoxide and carbon dioxide and hydrogen. So the specific conditions. Genesis, do you want to say that part?
Yes, ¿me escuchan? ¿Me escuchan?
Sí.
Okay. Bueno, specific conditions. The feeding of the gasifier, the thermal power of gasifier, the biomass, mass flow rate, and the producer gas flow rate are shown. Ah, no, aquí no están. Sorry. At the beginning, mass flow of producer gas, but it decreased quickly. So because of increments of pressure drop through the bed and because of the gasifier heading. Then the mass flow decreased slowly while the thermal power took a clear and strong decreasing tendency. Probably in this point, the bed was too dense for the gasifier to work properly. Later, the type of oxidant. Gasification takes place in a reactor, the so-called gasifier, in the presence of an oxidizing agent that may be pure oxygen, steam, air, or a combination of these. And okay, here are the temperature range. So the gasifier operates at 1,450 to 2,000 Fahrenheit, with syngas exciting at 500 to 1,400 Fahrenheit, and operating pressure. So here is the ¿cómo se llama la gráfica? Esta cosa. The graphic, yes. So the turbulence created by the combustion process creates a pressure drop. This can be measured using mesh with grids. This way we can observe how the pressure drops from a small selection of grids, and when the grid selection is bigger. And here we have a table with the head supply from the fact, aquí la de arribita. Y la que sigue.
Ah, perdón.
Thank you.
Okay, then we had the concrete examples of industrial gasifiers. We found that the producer gas is rich in hydrocarbons and especially tars, and therefore has a higher calorific value, which make updraft gasifier more suitable where heat is needed. For example, in the industrial furnaces. Or the producer gas needs to be thoroughly clean if you want to, the gas was, it is used to be used for generation electricity. Also, we found that this technology is mostly used in thermal application. For example, And then the expected performance is the process has a high thermal efficiency because the gas leaves the reactor at relatively low temperatures. And in the other hand, the product gas from an updraft gasifier thus contains a significant proportion of tars and hydrocarbon, which contribute to its high heating value. And finally, the conclusions. We found that this kind of gasifier has some advantage that are simple and low cost process. And also it's able to handle biomass with a high moisture and high inorganic content. But also we found that the primary disadvantage of this gasifier is that the syngas contain like 10 to 20% of tar by weight, requiring extensive syngas cleanup before engine, turbine, or synthesis application. And
That's all, no?
that's all.
So this system is one of the most efficient. Yes, it is. Y ya,
Do you have any questions, guys?
aplaudan.
Do you have any questions, guys?
¿Cómo les puedo compartir? Ya.
One thing that you didn't address is the syngas from that specific gasifier is not a clean gas, right? It has a lot of components like CO2 and some tar that you don't want that in your syngas, right? So it's a dirty syngas, and that should be well corrected afterwards, right?
Okay.
Vale.
Okay. So next up is Fernanda Martin, and I don't know if they're yes, Martin.
Sí, nada más somos nosotros dos.
Okay. So, hello. So Luis is going to be muted because he talks too much. That's it. Whenever you want to, guys, you have the share screen button on the lower part of the Zoom window.
Si quieres, ya la comparto, Fer.
Sí, okay.
Okay, so our team is formed by Fernanda and me, Martin, and we are going to talk about the downdraft fixed bed gasifiers. Well, first we're going to look a brief history of the gasifiers as general. Well, the German industries Bischoff and Siemens produced gasifiers since 1839 and 1861, and the syngas was used then for the ferrous metallurgy industry. And later, in 1881, Dawson in England developed a mechanism to purify and clean the syngas, and in that way, it could be now used in small furnaces and internal combustion engines. And it was during World War II when many ships, cars, buses, and tractors were powered by gasifiers due to oil scarcity. And here we can see some examples of cars that we can see that they had its own gasifier that produced the syngas in order to power them. These cars are from 1941. And well, here is a diagram of a downdraft gasifier. Here we can see that the feedstock is the site of the gasifier where the biomass enters at the top of it. And after the feedstock, we can see that it is found the drying zone when temperatures of 100 to 150 degrees Celsius are reached. And after this zone comes the pyrolysis zone, where temperatures of 300 to 500 degrees are reached. And here we can see that a process of decomposition takes place. And that is that there is a reassociation of the chemical bonds in presence of little or no oxygen. And after that, there is an air entrance here where the combustion process takes place. And in this part is where the higher temperatures are reached. And the TARDIS composition takes place, and that results on a less pollutant flue gas and a better conversion to carbon monoxide and hydrogen. And after the combustion section comes the reduction zone, where and finally is formed by carbon monoxide, hydrogen, and carbon dioxide mainly. And here in the top, we can see the main composition of the syngas. We can see that not only carbon monoxide, oxygen, and hydrogen is produced, but also it has a huge amount of nitrogen and methane also. And well, we are going to see the specific conditions in which the gasifier operates. We can see that this gasifier is generally used for the gasification of wood in biomass with the following characteristics. The biomass should be uniformly sized, especially in blocks is the best way to feed the gasifier, and it must be flowing at a constant rate. And also the moisture and the ash content of the biomass is very important, but because it has to be less than 20% and 5% respectively. And also the biomass that we are going to put inside the gasifier has to be of high density woody biomass, because in that way we can have a better syngas composition. And this type of gasifier is very sensitive to the size and the quality of the biomass feeding. Well, the type of oxidant is a very crucial parameter to regulate in this gasifier because it determines the calorific value of the syngas obtained at the end. And well, the common oxidants used in this gasifier are oxygen, water vapor, air, or also a mixture of them. When we use air, just air as the oxidant agent, the syngas will have a lower heating value, and that's why it's not good as if we used just oxygen. But the best thing that we can do is use just steam or even a combination of steam and oxygen. And here, here the temperature ranges in which this gasifier operates is very recommended that the gasifier operates at temperatures up to 800 degrees Celsius to achieve a high carbon conversion of the biomass and a low tar content. By reaching temperatures as high as 800 degrees Celsius, we can improve the quality of the syngas, the gas yield, the hydrogen, and get a higher heating value. And at higher temperatures, although the gasification process improves, it also increases the ash agglomeration. And that's why in practice, we opt to set process temperature around 750 degrees Celsius. And the heat supply normally comes from the biomass that is combusted. A fraction of it is employed with these ends. And since a high amount of heat is carried out by the hot gases, this type of gasifier is a little less efficient than the previous one that we saw with the previous team. And Fer?
Yes, the operating pressure of these gasifiers is often conducted under atmospheric pressure, or there are others that can be under high pressures. And the pressures are generally measured in centimeters of water column. And 1 atmosphere is equal to 1,029 centimeters of water. of these gasifiers in industrial processes. The first one is in the city of Lebanon, Tennessee, and it was made by the company Aries Clean Energy, and it has a full capacity of up to 64 tons per day of waste and produces up to 420 kilowatts of electricity. And it produces syngas and uses as fuel wood waste, scrap tires, and sewer sludge that are then converted to on-site electric power for the operation of the wastewater treatment plant that is on the city. And the other one is by Chess Group in Bulgaria, and this is a carbon negative biomass power plant because it, instead of producing tar, it produces biochar as byproduct, and it uses waste wood chips as fuel, and it's designed to generate 4.5 megawatts of carbon negative electricity. It can process up to 1.4 tons of biomass per hour, and the engine that they use to combust the syngas has a 38% efficiency, and it allows the generation of 2 megawatts of electrical power. And 2 megawatts of waste heat can be recovered to be used, and they can be used to dry the wet biomass. And as conclusions, the draft gasifiers are a good option for biomass as fuels because it is a competitive way to obtain fuel for combined heat and power generation. This type of gasifier requires the feed of biomass to be in very specific conditions. And also, as we saw from the previous example, there can be cleaner byproducts obtained from this process.
Very good, guys.
That's it, yeah.
Do you have any questions for them? People? No questions at all?
No, teacher.
No, teacher.
Okay, the only problem with that particular gasifier is that the heart of it, there is where the pyrolysis, where the combustions take place, is very difficult to design because any leakage of air will produce a different combustion, and if the heat doesn't stay on the heart of the gasifier, then the whole process starts to run badly, right? It doesn't allow for the reduction zone to convert the carbon dioxide to carbon monoxide and hydrogen and so on. So that's the problem with that gasifier, right? The easiest one, of course, is the first one that you presented. Now we have Diana, Sam, and Pedro, right? That were to present in train flow. Correct?
Yes.
Okay.
¿Quién? Diana, ¿compartes? O...
Okay. Sí, está bien.
¿Sí tú? Como quieras. Sí, acabo de ver el mensaje. Ok, va.
Un segundo.
Diana, dile que a Yani que deje de tomarse selfies, güey, que todo el mundo le está viendo.
Yo la voy a grabar. ¿Ya?
Whenever you want to, yes.
Pedro, ¿ya estás ahí?
Sí, ya.
Perfect. Well, we are going to explain about the infinite flow gasifier. And well, in these gasifiers, it's characterized because of the feed of coal that is oxidized with air or oxygen that is fed in the top of the gasifier. And this type of gasifiers operates at a high temperature and pressure that helps to create a rapid feed conversion, and that makes to convert the coal into energy. Well, this gasifier has been existing for more than 200 years, and nowadays it has become a better solution to convert energy because the natural gas has increased its prices, and also its transportation has been too difficult because it comes from different countries. And also this gasifier is fundamental for the technology of converting energy because that technology bases on synthesizing synthesizing any carbon containing material into gas. And this adds value to low or negative stocks from the marketable fuels products.
Okay, and there we can see the regions. As all of the gasifiers we've seen, the fuel is fed from the top, and then it's the drying phase. Then it's the same the pyrolysis, and at the bottom is the gasification. Also, the air is it filters from the bottom. I don't know if you can see it there, and the ash is also collected in the bottom. But this is like the general scheme. But this particular gasifier has a very turbulent flow. It even creates vortex patterns. So actually, all of that's why it says homogeneous reactions, because all of the reactions are happening at the same time. So it's kind of hard to pinpoint where the actual reaction is taking place. Next one, please.
Perdón.
Okay, so there we have the operating conditions. As we mentioned, this gasifier uses very high temperatures and pressures because the syngas we obtain from this is free of tar or oils, and that's why you need that high temperature to actually like melt or destroy that tar. So it's around 1,400 Celsius, and the local temperatures can reach even more. The operating pressure is from 20 to 70 bar, and you have to use, well, it's recommended to use pure oxygen as oxidant. You can use air, but it's not recommended because if you see at the bottom, the feeding of the gasifier, it doesn't matter if you use, stay there in the other one. Yeah, you can use solid or liquid fuel with this, but it has to be pressured. So if you use solid fuel, it has to be pulverized, and that's why you want pure oxygen, because if you have pulverized fuel, you have to use an inert gas to pressurize it. So if you get like usually you use nitrogen, and if you have even more nitrogen with your air, it's not good for the reaction. And then the heat supply, it comes with the pyrolysis and the gasification reactions that, like I mentioned, are running in parallel. Also, this one is because of the vortex patterns I was mentioning and the turbulent flow. The like the time it takes for the reaction to take place is very short. It's like 10 seconds usually. Next one, please.
And well, the applications of the gasifier, we choose two different companies. The first one is Shell, that we chose it because it has 50 Shell gasifiers around the world, and basically in China. And in those plants, there are gasifies 2,000 metric tons of coal per day to produce 253 megawatts of net electricity for the whole city. So in this company, the technology that is most used is the one that is applied at right fit pressurized. That is the one that Sam has explained in the in the last
Live?
slide, yeah. And this gasifier, what it makes is that it pulverizes the coal that is fed on the top of the gasifier, and through pressurized lock hoppers, it transport the gas that converts into syngas or nitrogen. Also, this type of gasifier works in a preheated 95% with pure oxygen and steam, and in this case they are mixed. The gasifier not only works with oxygen or not only works with air, it works with both of them. And the typical conditions is 2,700 and between 2,900 Fahrenheit, and with a pressure of 350 and 600 psi, so it can be produced as syngas. So also this technology is one of the most applied in the world because it only gave us products small quantities of carbon dioxide, and there are no hydrocarbon liquids or gases.
And this is another one that's a little bit different, but it's also used in China. It's from the Huaning Clean Energy Research Institute. And this is a two-stage gasifier. So I don't know if you can see my, well, the whole fuel is fed by in two parts. Like the first, I think it's in the bottom. You feed like 75% of your pulverized coal. It's there, yeah, and then there's a secondary coal. I don't know if you can see it. So that's actually to help the reaction, and then you have the water inlet, because I think they cool it down with water, and then at the top is the gas exit. So the entrance, I mean, if you see if you remember the previous diagram we showed, the feeding of the fuel is different. It's not from the top. It's actually like into parts from the sides of the gasifier. Can you go back to the Oh. And then it has high fuel flexibility. It can take as long as it's pulverized any type of fuel. Actually, it has low maintenance and it lasts for approximately 20 years. Then it has low O2 consumption, and in general, these gasifiers have very good conversion efficiency. It's typically above 80%, and over there, if you can see, it says it's over 99 for this one.
And while taking into account all the specifications of this type of gasifier, we can conclude that its main advantages are that it has a good fuel flexibility, but these can cause some problems that I will mention later. Well, it also produces generally a tar-free syngas, which this means that there is less residue to clean in the process. It has a very high carbon level conversion. It's, well, approximately 99%. It also is a short resident time process. And, well, according to the National Energy Technology Laboratory, it's considered the most environmentally benign gasifier. And, well, its main disadvantages ¿Se pueden cambiar? Gracias. Well, it needs large oxidant requirements to ensure all tar destruction and complete coal conversion. And well, it also needs these large amounts of oxidant because of the high temperatures that generally operates in. And as I said, it needs a high-grade fuel that it's correlated with the flexibility of its fuel used. Well, it mainly needs a high-grade fuel to prevent corrosion produced from all the gasification processes that are occurring on parallel. And that's it.
Do you have any questions, guys, about this one? This gasifier is one of the, as you said, guys, is one of the most efficient, but at the same time is one of the, well, you need to design it very carefully because the current of the oxidizer and the fuel in this case, they have to meet correctly in certain points of the gasifier for it to be gasified. If not, it's only going to be like combustion, right? So you need that a gradient of oxygen through the gasifiers, so at the bottom part of it you can have the reduction of, well, the reaction of reductions to obtain the CO and the hydrogen, right? So that one is interesting, but it's difficult to obtain good results and so on, right? So now we have team number 4, there is Gabriela, Monse, and Ricardo. Are you ready, guys?
Chicos, ¿quién comparte la pantalla?
¿Quieren que yo la comparta?
Porfa, ¿no?
Ok, denme dos.
Profe,
Claro.
oiga, ¿cree que haya posibilidad de que me retire?
No, prof, es clase completa y todos nos quedamos aquí.
No, es que van a cerrar ya la oficina porque no es
En el
aspecto.
celular te conectas.
Solo me están esperando.
En el celular te conectas.
Vamos a poner falta, Diana.
No, profe.
Qué oso, güey.
¿Ya? En serio, no hay nadie, vean. No
Dele las
estoy-
llaves a Diana y que cierre.
Estoy aquí encerrada por ella.
Güey, eres un desmadre, Janina.
O sea, un día en pijama y el otro te vas temprano, Diana. ¿Qué onda?
Profe, lo siento.
¿Un día qué?
Pijama.
Ay, estúpida.
Ve, Diana, tienes falta.
¿En serio?
Claro.
¿Por qué? No, ya nos quedamos.
A huevo.
Ante las amenazas.
¿Qué pensaste que dije?
Whatever you want to do.
No, pero es que estoy como el vato que vende brownies con mi papá y yo.
Ay, Isa, ¿puedes apagar? Gracias.
¿Ya ven la
Sí.
Mala onda, profe, qué mala onda.
Te dije que sí, Diana.
Ok.
Pero comparta, prof.
Ay, como te fuera a afectar.
Bueno, adiós.
Bye, Diana. Gracias por quedarte a escuchar mi exposición.
Y sigo, Mon.
Ya, después de esto te vas, ¿va?
Apúrense, apúrense.
Dale, Mon.
Okay. Hi. We're going to explain the moving phase bed. This boiler that can also handle fuels that are difficult to pulverize or less combustible. This technology has been used primarily by the pulp and paper industries to burn and wood, as well as a pit and other raw heat fuels. The next, please. A little story. The bubbling phase bed is a system that belongs to freeze bed combustions and the same history. And the first technology was invented for Mitsubishi Hitachi in 1984. Next one, please. Here you can see the diagram with the direction regions. The first zone is combustion. The combustion substance of a solid fuel is usually composed of element carbon, hydrogen, and oxygen. In complete combustion, carbon dioxide is obtained from carbon. In fuel, and water is obtained from the hydrogen, usually as steam. The combustion reaction is exothermic and yields a theoretical oxidation temperature of 1450 degrees. And the next zone is reduction, where the products of partial combustion and water, carbon dioxide, and uncombusted partially cracked and pyrolysis products. Now pass through a red hot charcoal bed where the following reaction take place. Heat temperatures in the reduction zone are normally 800 degrees and 1000. The lower the reduction zone temperatures was 700 and 800, more or less. And the next zone is pyrolysis, which takes place between 218 degrees to 500.
Okay, for the specific conditions, the feeding has to be chopped, pulverized, and reduced, and it also has to be dried for the gasifier to operate at high temperatures. The type of oxidant can be a combination of air, oxygen, or steam. The ranges are between 650 to 950. And well, the head supply, it's usually an additional combustion chamber. And well, the operating pressure, it is recommended more than 20 bar. This is to avoid a compressor, but is related to the feeding that has to be with those characteristics.
And well, we find like 3 concrete examples of industrial gasifiers. The first one was the KBR transport gasifier. It was tested and proven at the Power System Development Facility in Wilsonville, Alabama. It operates either with oxygen or air, as we mentioned before. The design is based on fluidized catalytic cracking technology, and the internal temperatures are like 1500 to 1950 Fahrenheit, depending on the fuel. It also operates at high solid recirculation rate, which results in excellent gas-solid contact in a highly turbulent environment. Well, yes, when the air is used, it's for power generation, and when it's used oxygen, it's for fuels production. ¿Le pueden pasar a la siguiente? This is the second example. It's called the high temperature Winkler gasifier. It was also tested in Germany. It also operates either with oxygen or air. and it has a dry feed pressurized dry ash gasifier, and it's capable to gasify different feedstocks, including low-rank coals with a higher ash softening temperature, and also many biomasses. And the result, well, the resultant gas, it has no high molecular weights, and the solids remove in the cyclone and return to the gasifier base to maximize the carbon conversion. And there's like the image of all the process. It's kind of complicated, but this is like a summary. And the next one. And this is the third example we found, and it's called the high temperature Winkler gasifier. It uses U-gas gasification technology. The fuel reacts at temperatures from 840 to 1100 degrees, and a pressure from 3 to 30 bar. The syngas can be used for heating applications, generating power, or making chemicals or fuels. In the reaction, big ash particles are formed, and the ash is removed from the fluidized bed by gravity. And this design ensures that the larger ash particles exciting the gasifier contains minimal amounts of carbon, and a lot of, well, they want to have like 95% of or more of the fuel's carbon that is gasified.
Okay. Well, this is what I was saying before, that particle size reduction, it's necessary, and drying the biomass. Also, gasifiers of this type are the lowest capital cost options for biomass, and they are also quite suitable for fuels, chemicals, and hydrogen production. That's all.
So, guys, I remember about the class that we have about what was the name of that one? Operaciones de transferencia de momentum. Well, that one, of course, yeah, we saw the bubbling beds, right? Well, it's the same principle, of course. The whole thing of using a packed bed is that, or a fluidized bed, is to have all the fuel getting everywhere, and the reaction is better, right? So that one. Okay, so now we have team number 5, that is Ale and Sofia. So, and whenever you want to, guys.
Listo, ¿ya se ve?
Sí. Yes.
Si lo pongo así también se ve. Well, we're going to talk about circulating fluidized bed. A brief history about this process is first that in 1921, Fritz Winkler discovers how to optimize the Haber-Bosch process and the main principle of coal gasification. In 1938, Warren Lewis and Edwin Gilliland discovered the fluid catalytic cracking and also the fast fluidized bed process. In 1960, Douglas Elliott also discovered the bubbling fluidized bed. And finally, in the 60s also, the Alstrom group started commercializing the first circulating fluidized bed gasifiers. For this diagram, first, the function of a circulating fluidized bed is mainly through a fluidization mixing process. And what happens in here is that the fuel is not burned with fire like the fixed beds, but it is what it's done in the circulating fluidized bed is that from the bottom of the chamber, air is supplied from under the bed at high pressures, and this lifts the bed material and the coal particles and keeps them in a suspension state. And in this state is where the coal combustion takes place. Also, the process of fluidization or the mixing is through this path. The particles of the coal that are not burned or combusted keep running through the cycle, and the gas that is provided by this process goes through this path. And finally, there is the syngas that all of my classmates talk about. And well, it's essentially that. It also, with the coal particles and all the fuel that is used in here, limestone is mixed, and this limestone captures the sulfur oxides, and this makes that the quantity of pollutants is not as big as in other processes.
The specific conditions, the feeding to the gasifier, steam is fed into the base of the fly-ash bed through a sparge pipe type of distributor. Type of oxidant is, well, in the most of the system is oxygen, but in some articles they prove with butane, but all the systems are with oxygen. And the temperature ranges are 850 to 900, and the heat supply burning of the char in the lower section of the bed, and the operation pressure is 285 bar, but the oxygen is supplied in the chamber, and they are primary air and secondary air. The secondary air can be in other levels to prove the combustion. This is a pilot plant that they produce 70 megawatts, and in this system they have primary air and secondary air. The temperatures are 600 to 800, and they use solid fuel like coal, and also the limestone to reduce the emissions of NOx and sulfur oxide. And this system is in place, it's in China. And this example is, they produce energy. They produce 150, and they have 2 cycles to improve the efficiency. You can see this cycle, the first in the part of this cycle, and then the other is more in the and these use coal or waste fuel like pine and bark, and their function is, temperature function is 555, and their pressure is 113.
Well, for our conclusions, first, this process has a lot of fuel flexibility. For example, it's not restricted to just one type or size of fuel, unlike some fixed bed gasifiers. For example, coal residue, wood residue, gas, and also agricultural waste like straw and husk can be used. And the efficiency is still going to be in the same range. In this case, the efficiency of this type of boilers goes from 97.5 to 99.5%, and this is also because it has a better gas-solid mixing because of the process that I explained earlier, and also because of the higher burning state that comes because of the fluidization mixture between the coal particles and the limestone. Also, because of the low combustion temperature, there are low emissions of nitrogen dioxide, and also are lower emissions of sulfur dioxide. However, the emissions of nitric oxide are higher. And also, this is something that we didn't put in here, but this kind of gasification process is used in the Fischer-Tropsch process, which is known as one of the main processes to produce liquid fuels from coals and also from biomass. So using this kind of fluidized bed boilers can make these type of processes more environmentally friendly. And that's it.
Very good, guys. Do you have any questions for this team? One thing that I find interesting about these gasifiers is the use of limestone, right? So they add a pollutant management system inside of the gasifier, right? That one is interesting, and of course the use of any kind of fuel is very interesting too. Sam, you have a question?
Yeah, I don't know if they explained it, but I didn't get why the pressure needs to be so high.
The what?
The pressure, I think they said it was like 200 bars or something like that.
Yeah, 200 bars around 200 atmospheres, right?
Yeah, is like, why is it so high? I mean, in the other ones, it wasn't that much.
Can you answer that question, girls?
I think because it's because of the principle of the process. I read a little bit about that, and to have the most of the coal particles in suspension, higher pressures are needed to allow this. If you have lower pressures, the air that is coming from the bed, it's not going to be enough to suspend the particles and also keep going the cycle in which the particles keep coming to the furnace until they become syngas.
Okay, thank you.
Okay. Any other question, guys? Or girls? Okay, thank you very much. So we have now the topic 6 with Isa and Monica. Whenever you want to, girls.
Okay, so we are Isa and Pamela, and we're going to talk about the dual fluidized bed gasifier. A brief story is that the pioneers of the DFB are D. Cooney, that in 1975 had a demo plant in Japan, and also the oxygen donor process was considered another pioneer of the DFB development. In 1984, the TNEE company developed a dual fluidized bed with a capacity of 500 kilograms of wood per hour and operated at 800 degrees Celsius. Also in 1992, FERCO patented a DFB biomass gasifier that had a low hydrogen content, but it had a high tar content between 23 and 32 grams of tar. What all of these processes had in common is that all of them ceased operations, and in the case of FERCO, the reasons why haven't been published. And up to 2007, an Austrian team worked on one DFB, and The advantages of that gasifier is that 90% of the water didn't react. In the diagram, the reaction regions are the gasifier and the steam react, and also the combustor with air. And then the char and bed material go to the combustor after the gasifier, and then the flue gas exits through here, the cyclone separator. Isa?
So usually the parts of the dual fluidized bed is first a bubbling fluidized bed for the gasifier, and as a combustor is a fast fluidized bed. And in the pyrolysis, the feed is the biomass, and it is fluidized with hot steam, boiled steam. And usually the materials used for this as a bed material are sand or olivine and quartz. And the temperature ranges of the bed are about 850 to 900 degrees Celsius. And in the endothermic gasificator, it is about 950 to 1,000 degrees Celsius.
Well, the first example that we found is a dual fluidized bed in Gusing, Austria, and the expected performance is 8 megawatts fuel power, 2 megawatts of electrical output, 4.5 megawatts of thermal output. It has an average of 81.3 total efficiency and a 15% of moisture content. Also, in the table, you can see the particulars that exit, that are tar, particulates, and ammonia. Here is the diagram of the plant in Austria, and here is the gasifier, the biomass enters with the steam, and they react. And well, the process is long. And the operating conditions are that the biomass is gasified at 850 degrees Celsius. The consumption of fuel is of 2,300 kilograms per hour. The real efficiency is between 65% and 76%. The thermal and electrical output are the same as the expected ones. Then the gas is cooled to about 160 to 180 degrees Celsius. The bed material they used is limestone, and air and steam enter the system at atmospheric pressure. Isa? Well, the 12 fluidized bed in Germany.
Sorry. Yeah, this is another example that uses logging residues, mostly wood chips, but also a percentage of bark and needles. And well, they have a variable particle size and moisture, but they usually produce they produce 15 megawatts of fuel power, which 5.1 megawatts of electrical outputs and 6.4 of thermal output. And you can see here the process. Well, the bed material that they use is olivine, and the biomass is gasified at 850 degrees Celsius. And they also use calcite to help also with like a catalyzer. And then in the combustion zone, up to 900 degrees are reached, but then the gas is cooled down in post-combustion. and the heat is used by heat exchangers, where they cool down the product gas, which is used to generate electricity and heat for the same process.
Well, the conclusion that we had is that the biomass gasification plants are a good option if the place has biomass available. In the case of Austria, they are like a little town that is surrounded by woods, and since it was far away from the cities, the government decided to create energy through the DFB on a plant, and they use the biomass available. Some advantages are that they don't produce CO2, and since the gasification reaction and the combustion reactor are separated, the gas is free of nitrogen, there are no liquid emissions, and there is lower tar because steam is the gasification agent.
And also an advantage of the process is that, well, the recirculation of the materials, for example, the char and the sand, first are in the pyrolysis and then they go to the combustion zone, and the heat that is produced in combustion serves for the process of the pyrolysis.
Well, and that's it.
Very well, thank you, girls. Do you have any questions for this team, guys? Nope, me neither. It was pretty clear what was the advantages and so on. So we're only missing one team, that is the plasma gasifier. So we have Rui, Edgar, and Gerardo. So any time, guys, whenever you want. You have to put the full screen as in any presentation in the lower right. Next one, another icon, another.
Edgar. ¿Quién está compartiendo pantalla, perdón?
¿Qué?
Edgar, es que arriba no hay, güey. A ver, si quieres, vuelve a descargar. Please.
¿Por qué?
Problemas técnicos.
Hay otra.
Rui, your microphone doesn't. I don't hear you very well. I hear you very quietly.
¿Así se escucha mejor?
Creo que sí.
¿No?
Sí.
¿Uno?
Sí, yo sí te escucho.
No, tampoco es esa. Rui, ¿se la compartes tú?
Well, we are going to talk about plasma gasification process. I don't know.
¿Ahí sí me escucho?
Sí, suave, pero sí.
Well, the plasma gasification is an extreme thermal process and it uses the plasma, which convert the organic matter into syngas, and it's made primarily of oxygen and carbon monoxide. A plasma torch powered by an electric arc is the one that ionizes it, makes the heat that burns all the material, all the biomass, and it is used commercially as a form of waste treatment and for gasification of the municipal solid waste. There is a picture of the plasma torch, and it's used a plasma gun, and it's provide the energy by DC current and AC current. It can be both, and radio frequency torch destroyers. The DC torches are the most commonly used and researched. Edgar?
Do you have the presentation, Rui?
Yes, I'm going to put it. Yo lo pongo. Sorry about that.
So we will start over again. First of all, we will go through a little bit of history. It's hard to find history about this process because it's quite new. But it was invented at first to decompose and destroy the hazardous waste and to melt ash from all the wastes. So it has been used for over 30 years, but the first big and massive applications were in Hitachi plant in 2002. That plant had a capability about 24 tons of municipal solid waste. The other plant that is bigger, also in Japan, is of a capacity of 3,300 tons of municipal solid waste, and it is able to generate like 7.9 megawatts hour. And here in America, we have the geoplasma plant that it is able to burn, to gasify from 1,000 to 3,000 tons of municipal solid waste. There are other enterprises developing this technology, and there are the names. Okay, so the diagram basically looks like this. On the left part, you have all the feedstock that it can be of various sources like industrial waste, commercial waste, even biomass waste, coal, tires, medical waste. And then you have the plasma gasification process. After that, the syngas obtained from that plasma gasification process is cleaned up, and you get the syngas for several applications. Next, please. When you zoom into the gasification process, you see that first at the top there's a drying phase. This is because when you get wet feedstock, you need a lot of more energy, and you obtain less syngas. So after the drying process, the drying part, right behind the bottom, you have the pyrolysis, at the bottom of the pyrolysis, you have an entrance of steam where the charge gasification and combustion happens. And in the most bottom part, you have the plasma torch or plasma intake, where the all melting phase occurs, and you get, as a result, slag and your syngas.
Well, this is the syngas, and the high temperature of oxygen prevents the formation of many toxic compounds, like nitrogen dioxins and sulfur dioxide, and this makes this process a lot much cleaner because of the intense heat of the plasma. So the feeding to the gasifier is primarily waste disposal. The type of oxygen is the less the oxygen, the better, and it's more efficient. So it's not required the oxygen, and the temperature ranges are over 2,113,000 centigrade, and the heat supply is from the gun is the plasma gun, and the negative of the operation is the negative pressure, the pressure by its name.
So if we want to talk about industrial applications of these gasifiers, the kind of best gasifiers we found of this technology was the ones developed by the Westinghouse Plasma Corporation, which can gasify about 1,000 pounds per day of municipal solid waste. And they are able to generate 50 megawatts in a combined cycle power production. With these gasifiers, you get 65,000 normal cubic meters per hour of syngas, and they consider this as a quick clean gas. This clean syngas can be used to displace a lot of other technologies related to fossil fuels. And just to like I mentioned, this kind of industrial gasifiers, we put the weight and the dimensions of that gasifier, the G65, which has a height of 25 meters, so it's almost like a building.
Well, this is the layer of the comparison about the process and the megajoules that can be generated of net output and input. And this is the Brighton system and the potential of the biomass. The conclusion is that this is a viable solution about talking about the feedstock, because plasma can reduce the waste municipal disposals, and it can burn also any kind of things because of the intense heat. Everything is evaporated or make it ash. And the main advantages of the plasma torch are that there is more clean destruction of the waste, and that the process is the ashes that are generated are not toxic particles, and you can dispose it in a secure place inside the earth, and
that is it. And the production is the value-added products metals is the for next slide. You can take those metals and sell it is as another income.
Okay, thank you very much, guys. Do you have any questions for the plasma team? Okay, well, I don't have either a question. It's an interesting gasifier. The main advantage, of course, is the way it can process anything that you throw into it, right? And that you can recover metals and so on. The problem is that to use plasma, you need a lot of waste to use it, right? It's not viable economically speaking. Chicos, hablé con los del gasificador de la UNAM y sí nos pueden recibir el lunes a las 10 de la mañana. Entonces, el gasificador de la UNAM se encuentra aquí. De hecho, si lo buscan así como planta de gasificación, lo encuentran. Está ahí, ¿no? Está en Avenida del Limán. Acá está Anillo Periférico, Avenida del Limán. Y la entrada es justamente por Avenida del Limán, aquí donde está mi mouse ahorita. ¿No? Entonces ahí nos quedamos de ver, bueno, nos van a dar la visita a las 10 de la mañana. Entonces digo, esto también se los voy a mandar por un mensaje para que todos estén en lo mismo, porque ya se desconectaron muchos. Pero bueno, el punto sería vernos como 10 para las 10, ¿sí? Para que todos lleguemos a tiempo. Yo voy a salir de acá muy cerca del TEC Ciudad de México. Si alguien, bueno, me dijeron que solo podemos llevar 5 coches, ¿no? Entonces, pues sí tendríamos que pues, utilizar, pues irnos juntos, ¿no? Yo voy a salir de acá muy cerca del TEC Ciudad de México y tengo pues 4 lugares libres. Si alguien se quiere venir conmigo, pues adelante, ¿no?
Yo. Ya pedí uno.
Bueno, ya pedí, ya hay uno, ya solo quedan 3.
Yo, profe, yo también quiero llevar el mío.
¿Tú quieres llevar tu coche o tú quieres venirte conmigo?
No, yo llevar mi coche.
Ok, vale.
Sí, yo también, pero igual salgo de Insurgentes, por donde está la WIC, si alguien ocupa o algo.
Yo salgo de la del Valle igual, por si alguien quiere.
Eso. Vale, entonces, bueno, el punto es que igual, o sea, digamos, ya ahí adentro no pueden entrar más de 5 coches porque no tienen, ¿no?
Pero se pueden quedar afuera, ¿no? O sea...
Sí, en la Avenida Limán hay mucho espacio. Nada más digo ¿cómo se llama? Nada más digo que dentro solo podemos llevar 5 coches. ¿Vale?
Ok.
Entonces, bueno, los que se apunten conmigo, pues los puedo recoger ahí enfrente del Starbucks a las 9:20, por ahí. Si quieren, me manden un mensajito por el chat para que sepa que se apuntan conmigo para nada más tener la lista, ¿no? Y saber quién sí y quién no. Y bueno, entonces, pues los demás, si se puede, si viven cerca más o menos uno de los otros, pues pónganse de acuerdo, ¿no? Pónganse de acuerdo y pues, tal vez llegamos en menos coches, ¿no? En vez de estar llevando tanta cosa. Tristemente, los gasificadores no están en funcionamiento, porque le están mandando equipo nuevo y otras cosas. Pero bueno, igual la plática acerca de gasificación y el tour por las instalaciones y ver los diferentes gasificadores y la explicación de cómo funciona, etcétera, pues ahí estará, ¿no? ¿No? Entonces, ese día, pues no tendremos clase en la mañana, sino que más bien nos vemos en los gasificadores y listo, ¿no? Sí, esa sería la clase del lunes. ¿Vale?
Ok.
Vale.
¿Alguna duda?
Ok, prof.
Luis, tú dijiste que sí te vienes conmigo, ¿verdad?
Sí, prof.
Vale. Bueno, entonces Martín y Felipe que se van conmigo y si alguien más quiere, pues adelante. Vale, entonces, pues eso. Entonces nos vemos en los gasificadores. Les mando un mensaje al rato. Para que todos tengan lo mismo. ¿Vale? Bueno, gracias por las presentaciones, chicos.
Gracias, prof. Bye.
Nos vemos.
Chao.
Gracias, profe. Bye.
Gracias, profe.
Bye.
Bye.